Oh, hey, what's up? Uh, Alge 1B. So hopefully you noticed I'm doing some different things, trying to add transitions and some fun stuff into the videos to make them a little more professional looking. So hopefully that looks pretty cool. Just trying to make it look a little better. So we did completing the square. Now we're going to keep doing that, only we're going to add in some uglier things. So the plan is to continue with that. We'll see how it goes. We'll keep playing it by ear. And if we need more videos or updates, I will add them as we go. But I've broken this down into real small chunks. So hopefully it comes across fairly simple, since we can't have a back and forth so well in this manner. So we are completing the square. Remember, when we are completing the square, what we are doing is we're trying to force that trinomial to be a perfect square. So the stuff we did before, it was all factorable. We could have done it with factoring. Now we're going to start throwing some things in that are not factorable. For instance, if you see x squared minus 6x minus 4, you might take a look at that and realize there was probably no way that was going to factor. Two numbers that multiply up to 4 add up to negative 6. How are you going to make that happen? 4 and 1, 2 and 2, not going to do it. So here's where we absolutely need completing the square. And some of these are going to have some irrationals, some are going to have some non-reals. Remember, we're going to have to poke our eyes out here. So we'll do a couple. I think I have 4 examples. I have you guys try 2 of them, and then we'll go over them together. So here we go. So first thing, when we're completing the squares, remember, we want a new C value, one that makes it factor into a perfect square. So the first thing that I'm going to do is I'm going to take that C value and I'm going to take it over to the other side. I'm not going to show all those little steps just because I have very limited room here. So hopefully all that makes sense. I'm just adding 4 to both sides. So now we need to come up with that new C value. Remember, that new C value is found by taking the B value, dividing it by 2, and squaring it. So our B value in this case is negative 6. And if I take negative 6 and divide it by 2, I'm looking at negative 3. And before I square it, remember, that's our little way to cheat how we can factor it. Negative 3 squared, of course, is 9. So what we're going to wind up doing, now that we have that 9, is we're going to add that in to both sides. So when I do that, I now have a couple things. One, over here, got 13. That's pretty simple. Over here, what this will now do is this allows you, let me leave a little more room. This allows you to factor this as a binomial squared. And of course, this little cheater thing here tells you what it's going to be. It's going to be x minus 3 squared, which if you envision x minus 3 times x minus 3, when you did your outer and inner, you would get negative 3x and negative 3x, which is negative 6. And when you do the last, negative 3 times negative 3 gives you the 9. So it factors nice and neat. Now at this point, we're going to use our square roots to solve. Since I have an item squared over here, this binomial, I can square root to make that square go away. Of course, when we do the other side as well, don't forget your positive and negative. When I square root x minus 3 squared, that just becomes x minus 3. Now, this is where it's slightly different. The square root of 13, well, guess what? It's the square root of 13. This is just positive or negative root 13. That's all it is. So to finish this up, we're going to add 3 to both sides. Now, the only problem with that is if I try to add 3 to the square root of 13, I can't. So what I'm going to do is I'm going to write that answer in this manner. X is going to equal, we're going to put 3 out front and write it as positive or negative 13. Forgot my root. Positive or negative root 13. So this is actually 2 answers. In fact, if you look, when you start doing them and look at the answers in the CUDA worksheet, they'll list them as 3 plus the square root of 13 and 3 minus the square root of 13. Which we could we could get an estimate for that and come up with estimates, but those are the exact answers. We'll use them in the roots when we do parabolas down the road. But those are our two answers. I usually write it this way. It's just a more concise way, so you can leave it as 3 plus or minus root 13. So two real answers, they just happen to be irrational. Let's try another. Let's take, we've got x squared plus 10x minus 5 equals 0. So once again, this guy's unfactorable. So when I take a look at him, I go, okay, well, there's no way I can come up with two numbers that multiply up to 5 and get me a 10 when I add. So what I'm going to do, complete the square. Remember, we're finding a new c value to make this factor as something squared. So the first thing I'm going to do is I'm going to take that 5 to the other side, and I'm going to have x squared plus 10x equals 5. Coming up with that c value, that's where we do our b over 2 squared. My b value in this case is positive 10. 10 over 2, of course, is 5. And before I square it, take note of it. Helps you factor it. 5 squared, of course, is 25. So we're going to add that thing to get a new c value. Of course, to keep the equation equal, we got to add it to both sides. So now, I know that this will factor as a binomial squared. And of course, 5 plus 25 is 30. So x squared plus 10x plus 25 will factor as x plus 5 squared. Easy enough. What two numbers multiply by 25, add up to 5? Well, it's 5 and 5. Or you could have just gotten it from taking this little cheater thing there. So at this point, we're going to solve. We're going to solve using roots. I'm going to square root this side. I'm also going to square root this side. Don't forget your positive and negative. Square root of x plus 5 squared is just x plus 5. Root and the square undo each other. Over here, I have positive or negative square root of 30, which is just positive or negative square root of 30. There are no perfect square factors of 30. So now we'll go ahead and finish this. We will subtract this 5, subtract this 5. So x is going to equal negative 5 plus or minus the square root of 30. Again, we could write that out as negative 5 plus square root of 30 and negative 5 minus the square root of 30. But this says the same thing, and it's a little easier to write. Hopefully you're finding this fairly simple. Again, it's an irrational answer. It is a real number, but it is irrational. And those will be the roots of our quadratics when we graph them down the line. Next one. We're looking at b squared minus 2b plus 7 equals 0. Once again, not factorable. The only factors is 7 or 7 and 1. No way you're going to get a negative 2 out of that. So what we're going to do, come up with that new c value. So we start by taking that 7, pushing it to the other side. It becomes negative 7. We come up with our new value by doing our b over 2 squared. I'm going to jump right to negative 2 over 2 squared. That, of course, is negative 1 squared. That tells me how it's going to factor, and negative 1 squared is positive 1. That's the new c value that we are adding in. We must add that to both sides. This guy is going to factor as b minus 1 squared. Over here, negative 7 plus 1 is negative 6. Now, wonder if some of you guys are looking ahead, realizing we're going to have a non-real answer here. So I'm going to solve by rooting, and I'm also going to root this side. Don't forget my positive or negative. Now, square root of b minus 1 squared is just b minus 1. root and the square undo each other. Then over here, we've got positive or negative square root of negative 6. Now, 6 does not reduce, doesn't have any perfect square factors, but anytime we have a negative underneath that radical, don't forget we poke our I out. I root 6. We'll finish it up in the same manner. We will add 1 to both sides. That's going to give me final answer of 1 plus or minus I root 6. So it's obviously a non-real answer. And those are two answers. 1 plus I root 6 and 1 minus I root 6. Easy enough. I think we have one more. Then we're going to let you guys do it on your own. Last example. We've got f squared minus 8f plus 21 equals 0. So take a look at it. 21 and 1, 7 and 3. No way you're going to get an 8 out of that, I don't believe. So this is not factorable. So we're going to have to use completing the square here. Need our new c value. So I will start by taking that c to the other side. Subtracting 21 from both sides gives us that. Doing our b over 2. b is negative 8 over 2 and squared. That is negative 4 squared. There's my little cheater. Negative 4 squared is 16. That is the value of our new c. So we will add that in to that side. Of course, we do the same thing to both sides. This guy will now factor as a perfect square. F and negative 4. So this is f minus 4. Over here, negative 21 and 16 is negative 5. At this point, I can solve with roots. I'm going to square root. Going to square root. Do not forget your positive and negative. Square root of f minus 4 squared is f minus 4. Positive or negative square root of negative 5 is just going to be positive or negative I root 5. Cannot reduce the root, however, we can poke our eye out. Last step would be to add 4 to both sides. We're looking at f equals 4 plus or minus I root 5. So hopefully those examples make sense. I'm hoping we're going slowly and step by step that we're getting it. I'm going to put an example up here. I'm going to have you guys pause the video. Should be some cool transitions coming your way. Pause the video, give it a try, and then we'll go over the answer when we come back. So the first one I would like you to try is k squared minus 12k plus 40 equals 0. Pause the video, give it a whirl. Welcome back. Let's see how it went. I went ahead and put the whole problem up so we can talk about it. Obviously, you can skip down and see if your answer matches, and if good, go ahead and fast forward to the next example. So, new c value, we took the 40 over. It is negative. Our new c value worked out to be 36. Negative 12 over 2 is negative 6, and squared is 36. Don't forget your little cheater thing here. Added the 36 to both sides, gave us a negative 4. And of course, this guy will not factor as k minus 6 squared. Square rooting to solve, not forgetting our positive or negatives. Nice thing here is the 4 reduces out, so the root goes away, but you also have your I that pokes out there. So we wind up with positive or negative 2i. We then have to finish this off by adding 6 to both sides. That's going to give us k equals 6 plus or minus 2i. Again, you cannot combine that because one has an I and one doesn't. Same thing as having a radical. If you need to, go back over that, look over it, make sure you're okay with it. Next example, we're going to look at a squared plus 4a minus 7 equals 0. You know the drill. Try it. Welcome back. Went ahead and put it up again. So we had to get our new C value. So the 7 went over. New C value is B, 4 over 2 squared. 4 over 2 is 2. Squared, of course, is 4. So our new C value we're adding to both sides is 4 and 4. So that gives us, this guy now factors into a plus 2 quantity squared. That is 11. Square rooting to solve. Don't forget your positive or negative. That gives me a plus 2 equals positive or negative root 11. Irrational, but not unreal. Subtracting 2 from both sides, we end up with a equals negative 2 plus or minus root 11. I hope those went well for you. Again, if not, we will make some more videos and we'll get across. We can do a Google Meet and all that stuff. I hope you're all well, safe, happy, and I hope this distance learning is going well for you. I'm starting to get in a little bit of a groove, so I'm starting to feel better about it. But we'll keep working our way through it and make the best of it. See you guys.